Welcome, and thank you for joining us today for our third Recharge with Solectria webinar session of the year. Today, we will be discussing working safely around solar electric inverters and the ways you can protect yourself by minimizing risk. My name is John Lavelle, and I'm the Regional Sales Manager. I've been doing this a long time, and worked closely with Bob Bonzar, who will be leading our webinar. He's a senior product training engineer, and if you ever happen to sign up for any of the XGI 1500 hands-on training, it's a good chance you will meet him in person as he teaches many of the classes. With that being said, just wanted to give you a quick overview of Solectria and Yaskawa Solectria Solar. Solectria has been in this business more than 20 years and was acquired by Yaskawa about 12 years ago. And we offer made in America, domestic content qualifying, FIAC compliant, utility scale inverters ranging from 125 kW up to 250. We also offer a full line of string combiners designed exclusively for the XGI 1500 inverters. We'll be launching a 1 megawatt inverter next year, and we also offer power racks with AC combiners with virtual central building blocks, as well as the PVS 500, which is a DC coupled energy storage system. Here's a couple pictures of the products. The big one there in the middle is the 1 megawatt, which has yet to launch, but we're very excited about that. We're actually looking for beta customers. So if you know anyone that wants to help us in the beta process, we'd be happy to talk with you. And there are the combiners on the right and the XGI 1500 inverters on the left. So I'm going to hand it over to Bob, but I just have a couple more intro slides here. Here's a picture of the storage rack, the PVS 500 storage on the right and the power rack on the left. These are BABA compliant. And then this is my last slide here, and it's busy, but the big takeaways here are this is the Yaskawa umbrella, which Yaskawa America rolls up to and Solectria rolls up underneath. We have almost 5 billion in turnover, 100 years of power electronics experience, shipping to over 30 countries around the world, and almost 15,000 of associates worldwide working under the Yaskawa Electric Corporation, Yaskawa America, and Solectria. So with that, without further ado, I would like to turn it over to my colleague, Bob Bonzar, who's the Senior Product Training Engineer, who's going to talk about how to ensure that we all work safe when we're working on these solar electric inverters. All right, Bob, take it away. Thank you very much.
Thank you, John, and thank everyone for attending today. Just wanted to initially express that the importance of safety in general. Also, we do offer this webinar. You do get one credit for NABCEP credit for this webinar, by the way. This webinar is about talking about working around inverters safely, but it's not necessarily limited to that. I mean, we're talking power electronics in general. So we will discuss topics to stress the important working in this environment, putting focus on both PPE and being prepared, as well as putting an inverter in electrically safe state. This training is not going to certify you as a arc flash compliance. It's just merely what we would recommend and what we go over in our classes. So we make sure that people are working on equipment safely and correctly. So if you are interested and you need to be certified, please go to the NFPA 70E site and sign yourself up. They have both in-person as well as online classes. So if you are, again, need that or interested in that, please go ahead and do that as well. The agenda, again, is talking about preparation before servicing. You're going to need some tools, hand tools, multimeters. So you need some electrical equipment, as well as PPE. So PPE is part of your toolkit, but also is there to protect you. And then finally, we'll go over putting the inverter in an electrically safe state so that you have the ability to work on it without any hazards. So we'll discuss that in detail. So before servicing, what do we need to know? Might be some questions you need to ask yourself. Are you a qualified person? What does that mean, right? I think qualifications have a lot to do with experience, maybe having somebody take you under their wing ahead of time. Training, of course, that's another big component. Have you been trained? What kind of training have you taken? Read the warning signs. We'll talk about the different signage, not just obvious things, but what is the condition you're getting into? Who's your contacts for the site? Are you the only one on site? Hopefully not. And if you need to get into something that requires somebody to access, you have to find out who's going to let you in and so forth. Have you read the manual? Again, really big topic. We stress that please read the manual even before you do an installations, but also there's important information about the unit. But at the same time, we stress the safety, and those are right in the front pages of everything. Do you have the proper PPE? Like I said, we'll go into more detail of what we express in the class, but again, everybody's going to possibly have additional PPE, and that's okay. It really depends on where you're going and what the signage says about that. So we'll address all these topics during the webinar here. So again, in the manual, what's in the manual? Specifications and ratings. Again, talking about safety and hazard information, any useful information about the equipment that you're going to be working on. So, identifying the product. Is the voltage, what is the voltage of this product? Is it mounted properly? Is it the right height off the ground? What's the proximity around it for airflow? That's important stuff to know. Do you have the right cables attached to this thing? What is the fusing? So a lot of information in there. Don't discard the manual. A lot of times people will kind of breeze over, but it is that important, and I make a strong, important points in the classroom as well. Read the signs. There's a lot of different signage that can be out there. So some of the signs on the left there are things that we actually put on the unit so people are aware. First one there, it says caution. You want to give it 5 minutes after powering down the unit. Why is that? Well, this thing has capacitance in it. We'll get into that a little bit more when we talk about check-in power. Other signage, do you have the right PPE? Okay. Understand also that this equipment, if it's left non-operational, that you might need to, or you should actually have some sort of, way to mitigate that or use the desiccant packs. So again, come to my class and you'll learn much more about those in detail. Stuff on the right there, again, you might see this just about everywhere. When you're driving into a site, maybe there's something overhead, or maybe there's a construction still going on in some part of it. So again, adhere to the signs. Don't take anything for granted. Make sure you go home at the end of the day. So what are the conditions when you get to the site? What's the environment like? The terrain, maybe it's steep, or maybe it's not complete yet. Maybe they're in the process of installing a dirt path that will soon be a road. What about the weather? Is it conducive to your job, whatever you're going to do? It might be raining, so you might need to schedule another day. Maybe it's super warm and you need to put that big brim around your hat, or wear some sunscreen or something to help protect you from the elements. Animals. What about animals? My brief experience with some of the sites, we've seen some things like bears, some smaller animals, not really terrible, but they might actually chew on wires and things like that. So you want to make sure this kind of stuff. Some folks in different regions of the states have told me about different snakes and things like that. So you might need to wear like some sort of gaiters that prevent you from being bitten. So again, don't just take it for granted, that you're out there electrically working on things. There's other things that are out there to basically kill you. So just be aware of that. And again, access, contact, who's your contact, make sure they're available. Don't be the only one on the site. That's the other thing too. A lot of people say, okay, how do I get in here? But at the same time, they leave. And make sure, somebody knows where you are and how long you're going to be there. Again, sun shading, hats, pop-ups, things like that to help protect you from the elements. High visibility clothes. Again, what if there's other construction going on there? Or again, maybe they don't know exactly where you're on the site, but they can see you from the visibility clothes if you move around. So another thing that was really interesting is something called floating arrays or photovoltaics. That was a new term I learned recently, where people have the panels, the PV panels out on lakes or ponds. If anybody's seen that, I've not actually visited one, but I've heard some pretty interesting information about that. So I don't know about mixing water and electricity, but I'm sure there's some way to help with that. What else is there to look for? So again, keep these things in mind. It's not just about what you're wearing from an electrical standpoint. Think a little bit outside the box. This is where experience comes in handy, right? So tools. What kind of tools do we need? What are some of the tools that we use? So again, this is from the class. This is what we do in the classroom. But you might have more tools, and then as I found some people come to class and they said, "Oh, I need to get one of those," that type of thing. So I learned from folks, and they learned from me. But important things. If the size of the screw head says it's a number 2, don't go try to use a number 1. Or if it's a 3, don't be using a 1 on it. You can only strip the heads off. Same thing with different sizes of the sockets. Make sure you have the correct or a series of sockets. In our equipment, you'll run across Phillips and flatheads and Torx and metric sockets. So you're gonna have a bunch of different tools. Open end wrenches and adjustable wrenches to help maybe for backing, taking a nut off or something off the back. That might be helpful. Also Allen heads. So we do have Allen. So we got the whole gambit of things here in our units. But again, that's the thing. You might go to a site. Don't take for granted. The containers also like to keep something, the screws in. Don't just put them in your pockets. Make sure you can even label the little containers and know where they go back, right? No power tools. Again, this is a pet peeve of mine in class. We don't use power tools. Many times people use them because they think, well, I can get through this a little bit quicker, but then they don't realize what the torque setting means, or they'll, over torque something or break something. And guess what? You just voided a warranty. So again, when you're out there using these tools, as long as you know your tools, you're comfortable with the tools, I'm totally fine with that. But again, if you got to use somebody else's or you're taking things for granted, again, you're just asking for trouble going forward. So additional tools. How about test equipment? That's a tool, right? So we have multimeters and understanding which type of tool you need for it. So make sure it can measure voltage that you're trying to measure or monitor. 600 volts, 1500 volts VDC. I don't know if anybody has anything out higher than that or out of range. Some of these meters also will have a built-in clamp meter on it, so it's convenient to test out current as well. Another thing in class, if your meter should have an additional function for measuring not just resistance, but doing things like diode checks. So I'm finding a lot of people in classroom, I'm having to let them know, you make sure you make a good investment in the meter you got, because you're going to need to test these things out. And likewise, you want to make sure that you have a good quality equipment that's working for you. So every time you go out to a site or on site, you want to do, some people call it, I think they'll live, dead live. You're basically have this little device, and we do in class, where you would check the meter to make sure that it actually works properly, and then go ahead and test the voltage. And then after you're done, make sure you do that test again with a verifier, just to make sure you didn't fry out your meter, because that can happen. So don't take things for granted. Likewise, your meter on your equipment should be verified and tested and sent out at least annually. So take care of your equipment. That's important. Don't just, throw it in a bag and throw it in the back of your vehicle or something. Make sure it works all the time, especially when you're using it. And some of these have batteries, of course, right? So we got to make sure we have functioning equipment when we're using the testing. And then, of course, personal protective equipment. I'll get a little bit more into that in a little bit here. We have a video in class. So what I did is I was able to take some excerpts from it, and we'll show those in a little bit here. But again, this is from the equipment that we would typically show in class, and you should always use it around live power. But again, it's what I'm showing you is not limited to that only. You have might have other things to add to your list as well. Additional precautions, some prevention. So how many of us out there, I'm not looking for answers right now, but just kind of more rhetorical. How many of us out there have actually seen a static or ESD bag? What's that for? What's that all about? Well, guess what? They put that in there so that the printed circuit board is protected from being shocked or zapped, just by merely handling it. And people don't always necessarily think about that. But that's that important, because you might receive a piece of equipment, you install it, and guess what? It didn't fix the problem. Is there a problem with that piece of equipment or board that you received? Or did you accidentally break it just by handling it? So again, in our class, we make sure that everybody understands this, and I give out a static wrist strap to everybody so that they can properly clip it to a grounding terminal or a metal part of the frame. So then when they're handling the equipment, they don't accidentally zap it. Okay. Another thing is wearing some sort of examination gloves to reduce the exposure to contaminants. When I say contaminant, I mean this is things like we apply a deox grease to terminals, so it's not it's just not something you want to anything else you want to eat and get on your fingers. So by wearing exam gloves, you limit the exposure. But it's also easier to clean up. So when you're touching something and handling something, you just peel those babies off, wash your hands, and you're good to go. But again, understand there's additional things we don't always necessarily think about, but we will need to be able to service things properly. And then of course, lockout tag out. Everybody's got one, right? So you should have a lock that anybody in the world has a key to. Of course not. You are the only one for the key, right? So nobody else should have a key to that. It also should have a tag on it that has your name and phone number. Where are you at? Maybe you had a car breakdown on the way or something like that. So, want to make sure that your information's on there so they can contact you. And then sometimes there's also a little hasp like I have in this picture here. All that basically means is more people can put blocks on there and prevent, them from energizing the unit. If it's not, in a dangerous potential state. So if you're the only lock on there, you're the responsible party, but there could be other people there as well. So again, make sure you're aware of that. Now we're going to dive into the PPE a little bit more in depth. So again, personal protective equipment. What's in your bag, right? So as we go through this, we'll talk about each individual item I have here on the table. So the first thing is the coveralls, or your clothing. So just like anything else I've talked about, tools and whatnot, we always want to maintain them. We want to be able to use them, but understand that every time you use them, you're wearing them out a little bit. So you want to make sure you examine things, make sure there's no holes. Because this is there to protect us in the event of electrical hazard happens, right? The other thing too is that when you're washing these, don't put them in with your regular clothes. Don't use fabric softeners, because now you've just loosened up the fibers and you're going to be more susceptible to a hazard. So again, sometimes this equipment or this clothing should be a little bit more stiff than what you're normally used to. Okay. So again, keep in mind that this is something that can wear out, or if it's got a tear or snag or something, that's, these are all replaceable items. You're not. Next thing here is the shoes or boots. Again, insulating from the ground. You don't want to be one with the earth in this case, so you don't get zapped by a ground fault or something. So again, these shoes or boots, make sure that they are a good fit, but also that they are insulated, and that they have some sort of steel toe or composite toe to prevent anything from smashing your toes. Okay, so again, adhere to whatever the signs say on the site in case you need to wear something extra. Maybe they don't let you have the low rise, or maybe you need a higher boot that goes, you know, up past your calf or something like that. Again, pay attention to whatever the signs say. Glasses, or some sort of, if your glasses are, your prescription glasses are already verified for safety, make sure you have good shields to help protect yourself. Or they make glasses like these to fit over them. That's what I usually use. So some sort of protection for the eyewear. Also earplugs. You know, believe it or not, these inverters are pretty darn noisy. I'm sure everybody can attest to that that's heard them. But again, that's where you're at. You're working around the equipment, and it can get kind of noisy. So please adhere to that as well. And helmet and shield and some sort of face, you know, head covering like a balaclava. So again, protecting yourself from an arc flash episode that you hope never happens. Gloves, super important also, because you're going to be handling test equipment. So they don't need to have good dexterity, because really all you're doing is you're holding a couple test leads. Don't worry about, you know, using them to hold a screwdriver, using them to write something down. Okay, that's not what they're there for. They're there to protect you. So they've got a single use, right? And so we'll go through these a little bit more in depth. Just like anything else, we need to verify and make sure that our equipment is compliant and will work and is up to date. So just some things about it is, you know, take a look at that name tag or that stamping on the side of it. It's got important information. So it says what the gloves are rated for. It'll tell you the test date or the date it's going to expire. And then in the little red there, it'll tell you what the size of them are. So again, we want to make sure we have appropriate sizing. The test date or the expiration date is important. We need to test the gloves, and I'll show you in the next one, or explain about how to do that in the next one here. But understand that you should have your gloves sent out professionally to be checked at least twice a year, every 6 months. But if you're using them the more frequently, again, examine them, just like in the couple pictures here. You know, is there a little poke hole, or is there you know, a rip or a tear in between the fingers? These rubber gloves should not be breathable. Keep that in mind. You know, they're going to be, you know, hot and sweaty because, you know, they're there to protect you from thousands of volts. So usually in your gloves, or at least these are my set of gloves. I have the leather glove, the leather component. That's there to protect the rubber component, which is the insulating layer, to protect you from the higher voltages. And then I like to also use some sort of like a wicking layer, because again, as like I said, you know, your hands are going to get hot and sweaty in there. And I think in the wicking layer, just my opinion, it's easier to take those off, and you don't have to worry about anything after you remove them. But sometimes there's this little dust that they make also that you can use to help mitigate the sweat. Thing is that it's kind of messy, and if you also, not just you, but the glove itself, if you're not maintaining the glove, it can kind of, you know, tend to cause a problem with the glove eventually. So, and then again, not only checking them for cracks or tears, we can also pump them up. We have a pump here in the office we use it in the training class, and listen for any kind of air leaks. If you don't have a pump or something, you can do other ways of like capturing the air or kind of slowly roiling them up, like I'm showing here, to get air in there, and listen for those leaks. Again, if there's a leak, that's an ingress for some sort of voltage shock or something. So again, be very careful. And then don't just throw your gloves around, okay? Make sure you're putting them in the bag that they came with when you're not using them, okay? If you're taking them off, you're done, you're going to go grab some lunch or something later or whatever, you know, don't just throw them on the side. You know, put them back in that glove bag, because then you know where they are. And also, one thing I've learned from the training that I received is when you put them in such a way that the fingers are up and not down, because when your fingers are up, things, if they happen to fall in, they won't go into the glove. Okay, so again, just some little tidbits and tips that I've learned along the way I like to pass along. So that's our PPE. So now we're all suited up and ready to start working on some equipment. So we got to verify that things are safe to work on. So again, in our classroom, we have this checklist in our procedures that'll take you through the process of removing power, making sure voltage is not present. So, and this is a particular order. We want to remove the AC component of the voltage first, and then the DC component, and then make sure that all the LEDs and panels and lights and things are off, of course. But not just that. We want to go out and find those combiners, turn off those and lock those out too. Okay. So make sure that we don't accidentally re-energize something if we forgot about it. So the combiner box can be, 100 yards away or a quarter mile away. So make sure you keep track of all this stuff. And again, lockout, tag outs. And then, oh, there's just a note in here about one of our types of inverters. Sometimes when you start taking the covers off, you get into like this additional protection inside there, and that's okay. That's what it's all about, being safe, right? So we've got our PPE on, we've de-energized everything. Now we're going to start verifying that there's no voltage. So we got our meter. We grab our meter, we verify that it works. Then we go in and check our DC voltages are not present anymore, current as well. Then we go ahead and examine the meter again. Then we go back and we check our AC voltages and currents, and we check those guys out as well. So again, there's multiple points inside the inverter that we're going to take a look at that are helpful to note where these things are. And again, we want to make sure we have a safe environment to work on. So again, verifying the equipment is safe, like I said, going through that little checklist. So what are my sources of energy? How to identify them? Again, making sure that we disconnect them all. Don't forget the lockout tag out. Verify the absence of voltage. And own the job. Don't let somebody pressure you into something. I mean, you're out there. Like I said, you want to make sure you go home at the end of the day. So if you see something, say something. That's why I said sometimes it's better to have another person with you, because you're so focused on working on this equipment. You don't want some big hairy beast coming up on you there. So you got to be careful. So what are our power resources or sources of power? First things are obvious, I think. The PV from the DC coming in, right? And of course our AC that's connected to the grid. But inside these inverters, they have capacitors, and those capacitors will hold a charge for some time. So those capacitors, we want to make sure where they are and how to locate them, but also how to check them. So this is the inside of one of our type of inverters. And on the right there, there's a big old bank of capacitors that'll hold a charge for several minutes. It says 5 minutes because that's typical, because there's a little discharge board there. I don't think this is unusual for people that are familiar with the field, but just keep that in mind. Don't just immediately open things up and start working on them. We got to verify the voltage is not present. So then, like I said, we remove all our AC and our DC. There's an example of a combiner in the lower left corner there. There's an example of a picture of an array, so you can kind of see where things are kind of spread out a little bit. I think everybody's kind of familiar with that. Lockout, tag out, can't stress that enough, okay? Making sure that we have the sole key for that lock and that you have your information on that name tag. So now we're going to verify that we have no voltage. So it's just some screenshots here again of the video. So the obvious things are on the left and at the bottom, where we have the main terminals coming into the unit that are connected. You got your plus and minus for the DC. You got your A, B, and C for your AC coming in. So we want to make sure that we check everything. And like I said before, inside we got a capacitor bank there. So when you shut the DC off, the PV array, you disconnect it. All you're doing is you're removing the voltage that goes to those, inside the unit. You still have from that switch back out, just like I'm showing that picture, you might still have voltage there. So just because you shut a switch off, don't take anything for granted. You got to check everything. So that's why the top picture there kind of shows us, okay, we're inside the unit. Let's go ahead and dig a little bit deeper and verify there's no voltage potentials that are still there. All right, make sure that they're dissipating. And it should be anything like 50 volts or less, because by that time it should ultimately go to zero. But according to NFPA 78, it should be like, I believe, 50 volts or less. And that's been updated in the recent times, but that was something that it was always kind of taught. But again, no voltage is better. So here's that little verifier that I was talking about. So before we check our voltages, we want to make sure our meter actually works. So this is kind of cool little thing because it has a switch on the side where you can actually verify whether it's AC or DC voltage, which is kind of neat. And again, check the meter, check the voltages, check the meter again. Always make sure that your meter's in good condition. And again, just to review, going back to our list, we opened all the AC and DC services. We made sure that none of the lights and panels are still on. Everything's off. We've gone and located the other external sources like our combiners, locked and tagged out those guys as well. Remove the inverter covers if there's any additional shielding internally. And then verifying the absence of both the AC and DC voltages as well as the currents. Some people say, well, there's no voltage. Can there still be a current? Well, Ohm's law, right? You got zero resistance, you could have full current. And I think likewise, we could have full potential voltage and no current. So don't take it for granted. Again, going back to your electrical days. So in conclusion here, just to kind of review a few things before we get back to John. So in our review, what have we covered? Hopefully to the people that have been in this field, I shouldn't really be talking about too much new. Everybody should know this kind of stuff, but everybody that's not, or like I said, it's kind of surprising. A lot of people that go through the training, they're like, oh, wow, that's kind of cool. Where do you get that? So I'm like, a little nervous. But again, everybody, you want to make sure that people go away with some knowledge here, but also they want, like I said, you want to go home at the end of the day. Keep that in mind. All right? So we talk more about not just electrical, but physical, environmental, the weather, stuff like that. There's more than just the box. Think outside the box. So. And again, thank you for your time and listening to me. And hopefully you'll be more successful in your endeavors. So I'm going to turn it back over to John for a few more slides here.
All right. Well, thank you for that, Bob. Those are some good tips because it's pretty important that we can live to another day, and this can be dangerous if we're not properly trained. So with that, just appreciate that, Bob. And, just wanted to remind everybody that there is further ways to learn with Yaskawa Solectria Solar. We have in-person training as well as e-modules that you can participate in. Many of these are NABCEP. You can get your NABCEP hours, and they can be accessed on our website or by going to the training login site. We also invite you to tour the factory with a couple of weeks' notice and a sales sponsor. We can arrange for you to visit the factory and see where these inverters are built and watch the assembly line. It's quite the experience. And actually, the factory tour is included on the 4th day in the morning of the XGI 1500 hands-on training. So after you do the 3-day intensive, you pass Bob's test in the morning before you fly out. We invite you to take a look at the factory. Seeing is believing, and I think it's a really good opportunity. So join us for our next session, where our product manager of our DC coupled storage solution, Gwendolyn Espy, will be hosting the call, and it's entitled "One Bus, Many Benefits: Demystifying DC coupled systems," and that's scheduled for later this summer on Thursday, July 30th, and registration is now open on our website. So with that, let's just take a look and see if there's any questions. One question I see here: do I get NABCEP credit for this webinar? And I believe the answer to that, correct me if I'm wrong, Bob, but I believe the answer to that is yes.
Correct. Yep.
You can.
Yeah, you get one credit, right? Yep.
And good. And then someone else asks how I can get this presentation. And I believe this presentation will be sent out to everyone who registered. Definitely will be sent out to everyone who attended. But I think it'll also be posted in our training portal. And then one more here is, where can I get training for the NFPA 7 arc flash class? And Bob, I do not know the answer to that. Maybe you can help.
Yeah, sure, no problem. I mentioned it briefly at the beginning. Essentially, if you go online and you look for the NFPA 70E, and there's also a local company here that we work with that also provides that. So whatever your local electrical company, or like I said, that's what, go to your Google machine and look for NFPA 70E training. And we actually do it every 2 years where we're trained as a group, but we also have online training they offer if you've already been trained. And that's, so they both do synchronous and asynchronous training. I don't know if you can
All
see
right.
a few more
Well,
questions.
that looks like that's all of the questions, unless someone has something else.
Actually, there's a few more questions I just happen to see pop in here. If you don't mind, I can kind of field some of them.
Sure.
But we'll get through a few of them. But ultimately, just like John said, anybody that's registered here, we'll send this out, or you can always watch these at the on our website. So let's just randomly put some in, get them here. Person asked about, do you need composite toes, shoes to use for electrical equipment? Again, that's a good question. I think it really depends on, where you might be at or what you might be doing. I think they're a little bit more comfortable. The type of shoe I use, actually, instead of the like metal D shape that typically they kind of hurt your toes. Look for something that is a composite, but also, kind of a little more comfortable. A couple other things popped up here about training. Again, you can go to our, as noted in the web, this webinar. You can go to training.yaskawa.com and look for the next available class. They are filling up, and if sometimes we'll get people that will cancel, very rarely, and we'll be able to let you know. So we do keep a list of like a waiting list. So. Appreciate the other comments and good feedback. People seem to appreciate this. Thank you again. Really, I do. I think it's all about all the questions I see here. Like I said, we're gonna go through more of these, and we'll be able to and send that out to you. So, anything else?
No, I think that's a
Good,
that's a
John?
wrap. We want to thank you all for joining us today. We appreciate your time, and we look forward to seeing you in July on the next recharge session, or I'll be attending American Clean Power next week. And what else do we have? And we'll definitely be at RE Plus in November. We'll have a booth there as well. So thank you very much. Appreciate your time, and have a wonderful week.
Thank you.